Hi everyone, welcome back to the coding series. In today's video, we will be solving today's Leetcode problem, that is minimum number of seconds to make mountain height 0. Let's get started. Let's understand the problem statement given here. We are given an integer mountain height denoting the height of a mountain, and also you are given an integer array worker times representing the work times of workers in seconds. And they have clearly mentioned that all these workers are working simultaneously to reduce the height of a mountain. For worker I, to decrease the mountain's height by x, it takes worker times of I plus worker times of I into 2 and so on worker times of I into x. For example, if worker I needs to reduce the height of the mountain by 1, it takes worker times of I into 1, that is worker times of I seconds. To reduce the height of the mountain by 2, it takes worker times of I plus worker times of I into 2 seconds. Now you have to return an integer representing the minimum number of seconds required for the workers to make the height of the mountain to 0. Now let's understand this with the example. Given mountain height is 4 and worker times array is 2, 1, 1. Now if worker 0 needs to reduce the height of the mountain by 1, it takes, according to the formula, it will be 2 into 1. That will be 2 seconds. If worker 1 needs to reduce the height of the mountain by 2, then it will be 1 into 1 plus 1 into 2, that is 3 seconds. Similarly, the last, if he needs to reduce the height of the mountain by 1, then it will be 1 into 1, that is 1 second. Okay, note that all these workers are working simultaneously. Okay, if all these workers are working simultaneously to reduce the height of the mountain to 0, then minimum number of seconds required for the workers to make the height of the mountain 0 will be maximum of these seconds. Max of 2, 3, 1 will be 3 seconds. So the output is 3. Now let's understand the third example. In third example, given mountain height is 5 and we have only one worker. Okay. Now if he want to reduce the height of the mountain to 0, then according to the formula it will be 1 plus 1 into 2 plus 1 into 3 plus 1 into 4 plus 1 into 5. Then it will be 15. So the output is 15. How we can solve this? We can solve this using binary search. Let's understand. Okay. We can solve this using binary search. Okay. Now minimum second. Okay. To reduce the height of the mountain to 0, it will be 1. Let's take, if the height of the mountain is 1, if we have only one worker, then if he want to reduce the height of the mountain to 0, then it will be 1 into 1, right? It will be 1 second. So 1 second. Okay. Now we have to find the max second, right? Like if you want to apply binary search on any array, you have to have the first element and then last element. So we have the first element and we have to find the last element. Okay, to apply binary search on this array. How? Now let's take 1, 2, 1 worker times array. Okay. Now how we can find the maximum second? Okay, maximum second these workers takes to reduce the height of the mountain to 0. For suppose if worker 1 want to reduce the height of the mountain by 4, then it will be 1 into 1 plus 1 into 2 plus 1 into 3 plus 1 into 4. Then it will be how much? 1 plus 2, 3, 6 and 10. Similarly, if second worker, if he want to reduce by 4, okay, then it will be 2 into 1 plus 2 into 2 plus 2 into 3 plus 2 into 4. How much? 2 plus 4, 6, 12, 8, 20. And if last worker, if he needs to reduce the height, then it will be 10. Okay. From all this, what is the maximum time? Maximum time is this one. Okay. So in 20 seconds, all these workers can reduce the height of the mountain by 4. That can be the max, right? So now, according to this only, if we have worker time array, WT1, WT2 and WT3 as a worker times array. Okay. Now, first we have to find the maximum element from an array. Here also, what is the maximum? Maximum is 2. So with that only we got the maximum second, right? So similarly here, max element. Suppose if max element is WT1. Okay. Now max second will be WT1 into 1 plus WT1 into 2 and so on plus WT1 into H. Because if all these workers need to reduce the height of the mountain by H to 0, then this can be the maximum second. Then it will be WT1, 1 plus 2 plus and so on plus H, right? So this is the sum of n natural numbers, H into H plus 1 by 2. That is the max second. So we got the max second. How we have the WT1, because like you can get the maximum element from an array, that will be WT1. For suppose if that is WT1, we have the WT1 value, height of the mountain value. You can find the max second. Now you have to apply the binary search. Okay. Now we have L equal to 1 and right equal to max second. You can derive this max second like this. Okay. Now, so for how we can do the binary search for L less than or equal to R. You can just, this can be R. Okay. R. How we can find the mid? Mid is L plus R minus L by 2, right? For suppose, okay. Now, if now we have WT1, WT2 and WT3 workers for suppose, okay. And given mountain height is H. Okay, mountain height is H. Now, if worker 1 reduces the height of the mountain by H0, similarly the H1 and H2, then H0 plus H1 plus H2 should be H, right? Correct, right? Now, keep this in mind. Okay. Now, so if worker 1 needs to reduce the height of the mountain to H0, reduce the height of the mountain by H0, then according to the formula, it will be WT1 into 1 plus WT1 into 2 plus and so on WT1 into H0. Okay. Then he can decrease the maximum, then he can decrease the height with that second. Okay. For suppose with this mid, okay. Suppose if WT1, WT2 and WT3, every worker takes this much second to reduce the height of the mountain to 0. Okay. Like if worker 1 takes this much time to reduce the height of the mountain, okay, then with this, because all these workers are working simultaneously, right? Then with this second, they can complete or reduce the height of the mountain to 0. Okay. Now, if worker 1 needs to reduce the height of mountain by h0, then according to this will be mid. Okay. Now, what we can do here, WT1, it will be 1 plus 2 and so on, height 0. Okay, because at last you have to calculate h0, h1 and h2 with this mid second. If all these workers are able to complete or reduce the height by 0, then if this condition satisfied, then we can just return this mid, right? So you have to calculate this h0. Okay. Now what, WT1, this will be h0 into h0 plus 1 by 2 mid. Okay. Now you have to find this h0. We have the mid value. We can find according to this formula. Okay. According to this formula, we can find the mid. Then we have the WT1 from an array. Then it will be h into h0 plus h1. This can be mid 2 star mid by WT1. Okay. What is this? H square plus h equal to 2 mid by WT1, right? So now h square plus h naught equal to 2 star mid by WT1. Okay. Now just add 1 by 2 whole square on both right and left. Then you can, what this can derive, this is in the form of a square plus b square plus 2ab, right? So you can just nothing but a plus b whole square. Okay, so h naught whole square equal to this one. Now what? H naught plus 1 by 2 equal to square root of 2 mid by WT1 plus 1 by 4. Okay, now you can find the H naught. 2 mid by WT1 plus 1 by 4 minus 0.5. Okay, if WT1 reduces the height of the mountain by h, then it takes this much. Okay, similarly, if WT2 want to reduce the height of the mountain by h1, then the formula will be like this: 2 mid by WT2 plus 1 by 4 minus 0.5, right? So then you have to check, what you have to check, h0 plus h1 plus h2 should be equal to h, right? Should be greater than or equal to h. If WT0, WT1, WT2, if it takes mid second, if it take like mid element, okay, any mid element from an array, okay, if WT0, WT completes within this much second, like if these all three workers reduces the height by 0 within this second, then it should satisfy this it should satisfy this condition. Okay, we can get the H0, H1, H2. How we can do this? Now we have everything. Now let's write what you can. Now you can just for left less than or equal to right. Okay, for left less than or equal to right. Left value we have, right value we have here. Where? This one. Right. Right value is this one. Okay. Max second. This one. Okay. Square root of WT1 into H plus H1 by 2. Okay. Now, so we have left and right. So now take mid equal to left plus right minus left by 2. Okay. Now check for. Now check if reduce. This is a function. Okay. With this mid second, I will tell what you have to write in this function. Okay. Can reduce. Then answer will be mid, and if it can be like we can just if okay, if we answer is mid, okay, then we can just even like if we got mid as a 15, if all workers can reduce the height of the mountain within these seconds, we need to check like we need to check whether all all the workers can reduce within within 14 seconds also, right? We have to check that as well. Okay, now what you have to do, you have to do right equal to mid minus 1. Okay, and if not, else wait 1 minute. This is not clear. Okay, now for sorry, if reduce height, okay, then what you can do, answer equal to mid and right equal to mid minus 1. Else, in else part, if all workers cannot reduce within these seconds, then you have to shift left pointer to mid plus 1, right? Mid plus 1. Okay. Now I will and you can just return answer. Okay. Now I will explain what we have to write inside this reduce function, reduce height function. Okay. In reduce height function, what you have to do? First iterate over array, iterate over reduce function is height function steps. Okay, first iterate over an worker array. Okay, worker array. Calculate h0. For suppose if there are only 3 workers, calculate h0 with this formula and with this like both are same, just wt1 and wt2. So after calculating h0, h1 and h2, just append to the resultant height h0 plus h1 plus h2. Okay, if resultant height is greater than mountain height, given mountain height, then you can just true return true, meaning with that second, okay, with that mid second, all workers able to reduce the height of the mountain reduce the height of mountain to 0, right? Then it should satisfy this condition. Okay, so oh, here I have written, right? Huh. If you have to, in this reduce height, you have to pass, in reduce height you have to pass function, you have to pass mid comma workers array and then the height of the mountain, given mountain. Okay, if you're getting return output as true, then answer equal to mid and right equal to mid minus 1, because I have mentioned clearly why here. If workers, if they are completing within 15 seconds, we have to check for 14 seconds as well, right? Because what if they complete within 14 seconds also, then you have to return 14 instead 15. That will be minimum. Now let's code this solution. Here what I have taken, first you have to find the maximum work time, like maximum element from the workers array. Okay, after finding, what you have to do, left will be 1 and right, I have clearly mentioned the given the formula here for maximum second, where it is for max second, here for max second, for suppose maximum element is 1, maximum element is wt1, then it will be square root of wt1 into h plus 1 by 2. Similarly, this is that. Okay, and for now take, now why I'm assigning this answer as right is because let's take in the worst case, this is only the maximum time that you can complete or reduce the height of the mountain to 0. Then simply I'm assigning this. Okay, now as I mentioned, you have to do binary search on an array. You have left and right, mid you can calculate. In the reduce height, I have mentioned you have to pass the mid worker times array mountain height. This is the total height. Okay, for every worker time you have to calculate the height. This is the height. Where is that? See, this is the height. Square root of plus 1 by 4, that only I have written. 1 by 4 is 0.25 minus 0.5. Square root of 2 mid 1 by t1 plus 0.25 minus 0.5. And you have to increment that height to the total height. and you have to check at the last if total height is greater than or equal to mountain height. If it is, then you have to return true or else return false. So that will, you will check here, then adding this, then you can just return the answer. Let's see. Let's run the solution. See, all test cases are passed. Yeah, all test cases are passed. That's it, guys. If you guys have any questions, please do add in the comment section. Like and subscribe for more videos. Thank you. Bye.